All right. Without further ado, Mr. Chris Gates.
Hey, Can we? All right. Welcome, everyone. We're going to talk about attacking Oracle with the Metasploit framework. So who am I? Chris Gates, member of the Metasploit project. Contrary to the articles, I didn't invent it. What pays the bills? I pen test, blog, kernel ownage at Attack Research, and then some other stuff. If you want more, bust out your Maltego license or just ask me. I'm here all week. So quick disclaimer, this is not my employer. And also that this stuff is really old. All the stuff that we're going to talk about that we've implemented in Metasploit is actually not new at all. It's been around for many, many years. But what's the problem is it's been random Perl scripts, random SQL files, and been kind of hard to put a whole attack together. So what Mario and I tried to do was kind of streamline the process for the pen tester. So why? Been on several pen tests and seen lots of Oracle targets. Because of the Oracle business model, you have to pay for updates. So what I kept finding is people would be in one camp where they would say, you'd have one guy whose own personal hell would be the DBA and he'd have to keep up with the Oracle boxes. And the other guy I'd ask, hey, you got Oracle on your network? Do you have a Metalink account? And they'd be like, what's Metalink? So what that gave us was the opportunity to have the potential for lots of shells. And then what we discovered was privilege escalation is easy. But shells are always better because this is Metasploit. So why focus? Not much in the way of Oracle attacks, especially from non-memory corruption bugs in the 4P frameworks. Saint does have some modules that will attack memory buffer overflows in the default packages, but that's about it. So some other tools that do attack Oracle and Guma, not really sure the status of that. Orasploit that was never publicly released. Pangolin, it's like a Win32 one, which happens to send all its data back to China. So if you want to give your hard-earned shell back, you can use that tool. Then there's some other tools that focus more on Oracle vulnerability assessments and less on pen testing and getting shells. So we had a couple modules that are already in there. There's an XDB, FTP, HTTP overflow, Pusscats WebLogic module, and some TNS exploits for Oracle 8. Then we've slowly over the last year been pushing out the auxiliary modules, which are doing version identification, SID enumeration, then SQL injection, some post-exploitation tasks. And the SQL injections have been file format where we would actually output that code to a .SQL file, which you would run inside your Oracle Instant Client. And an NTLM stealer, which Alex from DRSec wrote, which is really fun. So what we've got an introduction of a TNS mixin, which allows us to very quickly send TNS commands. This is handy because it actually crafts the TNS packets for us on the fly. So instead of the old days where we had to structure the TNS packet in our Perl script, Metasploit's now going to handle all that for you in the back end, and we use it for our TNS exploits and for our some of our auxiliary modules. And the big kind of release for this is an Oracle mixin. Handles the database connecting. So it handles behind the scenes, connecting to the Oracle database, sending your SQL query, parsing the results, and giving you that back. It's got a couple dependencies. You've got to have the Oracle Instant Client. And then you have Ruby DBI and Ruby OCI 8. The instructions for getting that going is at that URL. It's on the main wiki for Metasploit. So right now it's supported on Linux and OS 10. If you can get it working in Windows, I'll buy you beer. If you can get it working before Saturday, I'll publicly buy you beer and tell you that you're the man or woman. So what this does is it makes sending SQL queries to Oracle really easy now. You just pass whatever SQL you want to pass. So in this case, select star from global name and run it, and it gives us the results. And we've already got Dark Operator who's already working on some admin checking scripts. So once you've got creds, or if you have creds, you can use these tools to actually do some checks for you. So just a really handy function. So from an attack methodology point of view, kind of erasing the black magic of Oracle pen testing, I need 4 things to connect to an Oracle database. I need an IP it's IP, the port that it's listening on, the service ID, and the username and password. So the SID is crucial. If I can't find the SID for the Oracle database, I can't actually make any connections. So there's actually a handful of modules in Metasploit that will actually help us try to track that down. So that's our first one, user port scanner of choice. So next is determining the version. We wrote a TNS listener version module. All this stuff is in the trunk right now. It basically just sends a TNS packet with a version command and just parses out the results. And I haven't come across anything that was actually listening that wouldn't return that answer. So that's pretty handy. It's also got, it's scannerfied, so it will do the class Cs for you. And it's also got the report mixed in, built in, so as you can dump that output out to a database if you're choosing to do that as well. That's kind of what the DB note stuff down at the bottom is. Next step, determining the Oracle SID. Again, so for Oracle prior to 9.2.0.8, it would actually, if you asked for it by sending it a status command, it would give you all the service IDs and the service names that were running. After 9.2.0.8, they fixed that to where you now have to do some other things, like brute force it, so we can throw a dictionary attack. So we grabbed the red database security default SID list, and it just loops through that and asks it, hey, are you Oracle? Are you Oracle 9? Are you Oracle 10? And if it gets the right answer, it tells you that it found. So in this case, we found that the SID was Oracle. Of course, you'd also want to look at, see at the organization's website, it may, Metasploit, would have Metasploit for a SID or whatever. You can also query other components that contain it. So if they're running Oracle Enterprise Manager, a lot of those have like extra Java servlets that run that will actually return the Oracle SID for you if you query it. So we've got a SPY SID one that does Enterprise Manager. So there's a couple that you could run that will actually query it and parse out the results for you. Again, scannerfied, so it will run on the Class C for you. Next step. So if you can't otherwise acquire a username or password, or you've had your scope limited enough that you have to use some brute forcing techniques, we've got a login brute script that will actually take Pete Finnegan's default username password list, and you can add to it, and it will just rip through all the default Oracle accounts. And it does that pretty quickly. And it also outputs that to a text file on your box, so it allows you to query that later. Okay. Now, I guess for the fun stuff. So this is our typical setup. At DEF CON, we're actually going to get into the nuts and bolts of what's going on behind the scenes with actually creating the SQL injection modules and the IDS evasion. So this is your typical Metasploit setup. Set a remote host and set those four things that we needed: the IP address, the port, the username and password, and the SID. So those things that we were looking for is what we got to enter in there. This is what it looks like. We set our SQL to whatever we want it to run. So instead of it always being grant DBA, we've added a SQL variable, so you can pass it any SQL that you want to pass. So in this case, we're attacking the package owned by sys, the LT, and the find, and there's a SQL injection in the find RIC set procedure. So that's kind of what it looks like. It creates a random function name, executes the SQL injection, and then removes and deletes the function. So we can take a look and see that in this case it worked for us. Scott's now DBA. This is our initial coverage that we're pushing out. This should give you a good overview of exploits from all both sets of 9, 10, and 11. We've got cursor modules that will exploit Oracle cursor injection, regular SQL injection, and then some modules that do the IDS evasion. So if you guys want to start contributing, everything you need to get started should be there. Last step. So post-exploitation. If all you need is data, all you need to do is prove that you had access to the database, you've got an SQL.RB module that will actually allow you to execute any simple command you want. So at this point, we can dump system hashes, we can run queries, we can add permissions to whatever. I've been on pen tests where I handed somebody that and they didn't know what to do with that or what that meant in the way of access. So we kind of said, well, all right, well, if I get a shell, maybe that will show you that I'm a little more serious about what's going on. So there's a whole bunch of old published methods for doing this via Java. So we can make some Java classes that will actually execute OS commands for us. We can do external proc backdoors, execute or do OS commands with DBMS scheduler, or in fact, because Oracle installs Perl and Java by default, you can pretty much write any custom PL/SQL you want or any Java, and it will run. So the two modules that we pushed out last night, and we're going to push out some more before Saturday, is the Win32 exec, and what this does is you grant the user Java sysprivs. It creates a Java class and allows you to just execute OS commands. So, example, you can do net user add, you can TFTP your backdoor over, you can write FTP batch files, or if you do a net user add, you can throw those creds into Metasploit and do ps-exec exploit, if you want. It's actually a video of that floating around. I did a demo of that at ShmooCon doing just that. And that's kind of what it looks like. Set your command to be whatever command you want to run on the other end. And it creates a Java class, creates the procedure, executes the command, and then deletes those things and cleans up after itself. So the other one we pushed out is a Win32 upload. Again, you need Java sysprivs, and what this does is it downloads a binary from a remote web server, so no SMB required. Downloads the binary to the box, and then you can use Win32 exec to actually execute that binary. Again, that's old stuff. This was from Black Hat 2005 that the guys from Argenus released that. All right, so I've got time, so I'm talking fast. All right, so we start off with doing some version identification. We see that the box is a 10.2.0.1 box. Next thing is we're going to try the city num. Now, we know that because it's a 10 box, it's not going to work. We're going to get a listener protected answer back, but we can always try. If that had been a 9 box, it would have given us the SIDS listening. So next step's to do the SID brute force using that dictionary tag. It's got a sleep module, so if you're doing this across a slow link, you can actually set that sleep for you. On a LAN.1 is probably good. So in this case, we found a SID of Oracle. So now we're going to try and see if we can get some usernames and passwords on the box. And we just kind of left that verbose for now so you can see that it's actually doing something. It's a pretty big list, so I wanted people to be able to say, hey, this thing is still running. Once that's done, you can cat the log file and the data wordless Oracle default accounts log. You see we found Scott Tiger and DB and SMP. So next steps, we're going to go ahead and check and see, we're going to use the Scott account, check and see Scott's privileges using the SQL.RB module. So we'll just do a select star from user role privs just to see what kind of access he has. So you can see he's got connect and resource. So this will allow us, that's enough privileges to allow us to create our function on the other end and execute it. So we're going to use the LT find rex cursor exploit. Again, just fill in the gaps. So remote host, username, password, and SID, and then whatever SQL you want to run. So that was it. That's pretty quick. It just takes the package, executes it, and then we'll hopefully everything will work. We'll go back and check. We see that now Scott is DBA. Once we're DBA on the box, we can actually add the Java sysprivs. All right, next step we're going to do is we're going to set up the Win32 upload to actually upload our binary. So we're just going to pull this down off my my remote web server. System interpreter reverse callback. And you'll have to trust me, but it wasn't there before I started all that. So we'll set up our multi-handler to call catch the actual callback for us. So again, we create the Java source, create the package. The package is actually going to execute, grab the binary from the web server, write it to the local OS, and then we clean up when we're done. I see that it made it there. And then we'll use the Win32 exec module to actually execute the binary we put over there. And on the other end, on the remote end, we're getting our interpreter shell. So that's pretty much it. So thanks to all those guys who've been helping us out with the code. Any questions? Got time for one. All right, thanks.